Hello everyone, welcome back. In this final example this week, we are going to talk about functions that have what's called a return value. Okay? So what's a return value? Well, we're already familiar with some functions that have a return value. Let's take a look at the reference. Let's look at one function that we've been using quite a bit, map. Okay? Map is an example of a function that has a return value, which means map has some code inside of it, right? That runs based on the parameters that are provided. But then unlike the polygon function in the previous example that just did some work, drew some things on the screen and then ended, called it a day, map actually outputs a value. It outputs a number at the end, and then we can catch that number and put it into a variable. Okay? So that's what it means for a function to have a return value. It's not only the function going to do some work, execute some lines of code, when it's finished at the end, it's going to output some kind of answer, some kind of number is going to come out. It could be it could be any variable at the end that gets returned back to the program who called the function. Oftentimes, these will be functions that do calculations, like map. Another one that we use quite a bit that has a return value is random, right? Random random is a function that returns something. I say random between 0 and 50, right? And then it spits out a number that we can catch and put into a variable. Okay, so functions that return something, right, are typically calculations, but not always. Sometimes you might have a function that takes in an object, does something to that object, does some modifications, and then outputs the transform object back to the program. That can happen. Um, in this video, I want to talk about what the syntax is to return something and give an example of how we might want to use that. So like I said, a lot of the functions that return values tend to be functions that do math and calculations. And we're not really diving super advanced into any of this in this series. Most of the math functions that we could imagine already exist in P5. Things like random, constrain, map, all these functions are already there. So we're going to instead create a simple little example where we are going to define kind of a collision function. And this is an idea that we're going to use later on for our game. We're going to write a program that's going to draw randomly a bunch of circles. Okay, you know, I love circles. And we are going to change the color of these circles as the mouse rolls over them. Okay, and then once we've done this, we're going to talk about how we would take the rollover portion of the code that detects if the mouse is over a circle and kind of package that as a function that will have a return value. And that's going to allow us to do an example of a function that has a return value that isn't necessarily super advanced math. Okay. So before we can do that example, let's set the stage here and build a simple little program. I'm going to do this really quickly because this is things that we've done before. I'm going to just narrate as I go. We're going to create an array called circles. Okay, and in setup, let's make 100. I always pick 100, but of course it could be anything else. We are going to go into this circles array using our index, and we are going to define a number of objects. We're going to create objects. Remember, objects are between curly brackets and they're little packages of variables, at least for now. We're going to build on that object notion in the coming weeks a little bit more. These circles will have random x values, random y values, and also random diameters between, I don't know, 50 and 100. Okay, it's not really super important, just so we have something to work with. And then in draw, we are going to iterate over the array of circles we just made. Then for each circle, we are going to draw. Oh, bad idea. Okay, so I cannot use the variable name circle here because my command is called circle. So backtrack. Let's just call this C. Okay, so I don't want to use a name that exists in the language. So be careful with that. C works. It's short. Okay, we're going to simply draw a circle using the values we created up here in our 100 objects. And here they are. Okay. All right, we've done this many, many times in this series already. What we're going to do here, a little bit different, is we are going to check where the mouse is, and we're going to ask if the mouse is over one of these circles, we're going to represent that by changing its color as we're about to draw it. So how do we know if the mouse is over a circle? This is very easy. This is the easiest form of collision detection we can do in code. We're going to use the distance between the mouse and the center of that circle. And if the distance is less than the radius, we know we're inside. And if it's more than the radius, we know we're outside. Okay? So let's calculate that distance using our trusty distance function. We are going to calculate the distance between the mouse and the center of the circle, which is c.x, c.y. And if that distance, we can use an if statement, if that distance is less than the radius, right? So what's the radius? It's half the diameter, c.d divided by 2. If the distance is less than the radius, we know the cursor has to be inside that circle. So we're going to set a different fill color. Okay? Else, we're going to set a white fill. Okay? So this if statement will set one of two colors based on the answer to that question. So now we have created a simple kind of rollover behavior. Okay? Obviously, we're not going to go any further in this particular example. You know, we could put this into like a mouse pressed event, for example, and then we could have an event that triggers only when we click on one of these. We could turn them into buttons, for example, right, and have something happen. But this is besides the point. What I wanted to do here is just have a little bit of code so that we can talk about creating a function that has a return value. So now, whenever my mouse cursor moves, right, we do a little calculation here that checks where the mouse is, compare that to the location of the circle. If the diameter is less than the radius, we set a different fill. We could think of this here as a function, okay, that does a job for us and then outputs an answer. This function could be something like that. We are going to create a function here called, let's call it isMouseOver. Okay. So kind of a weird name, but it's going to be a function that returns a value, and it's going to return a true or false value, or yes or no value. So I'm going to structure it like this because it kind of hints to me anyway towards a question, right? Is mouse over? And you know, we could make this very long, or we could say, is the mouse over the circle, right? We could make this as long as we wanted to, but obviously at some point function names become really long. So this is kind of a convenient little contraction. Okay, so if is mouse over a circle, this function is going to return yes or no, or true or false, based on the parameters, the inputs that it's going to receive. Okay? So what does it need to do its calculations? Well, it needs either, right, x. Let's start with this. Let's start with x, y, and radius. Okay, so if it knows a circle, or let's use diameter. Okay, if it knows the circle defined by x, y, and diameter, the job of this function will be to tell us, is the mouse over that circle? Okay, so we have this code right here already. So first we know we have to calculate the distance, okay, between x and y. And let's call this diameter. Okay, so this is because d is already taken by our variable here. So now we have the distance, okay? And then we're going to ask the question, if d, the distance, is less than the radius, which is diameter divided by 2. Okay, yes, we are inside the circle, so we are going to return a value. We're going to return true in this case. So this is the new keyword that is kind of the whole point of this lesson. So whenever we're inside a function, when we use the keyword return, what's going to happen is the function is going to immediately end. It's going to spit out some kind of an answer. Okay, so here we're returning the value true. So if the diameter, right, is less than that, we're going to return true. And then else, or in fact, we could probably skip the else, but let's just make it very explicit. We're going to return false. Okay, so this function is going to return either true or false based on this calculation. Okay, so this is an example of a simple little function that takes in a few numbers as the parameters, and then it's going to look at these numbers, do something with them, and then output an answer. Okay? And what that allows us to do now is we can rewrite this code up here as such. We can say if is mouse over c.x, c.y, c.d. Okay. And in fact, this is kind of a weird syntax. We could write mouse is over. Yeah, I prefer that. Let's rename the function to mouse is over. Okay, just renamed it over here. So if mouse is over, and then we give it the parameters, then set a fill, or else set a different fill here. I decided, I did not include the outcome of the question into the function in this case because, we might want to use this concept down the road. Imagine you're writing a bigger program, right? Now, every time in our code, we want to know if the mouse is over a particular circular area. All we have to do is reuse the function we just created, right? So this is going to return true or false if the mouse is within the circle defined by x, y, and diameter. Okay. So now we've created a little reusable nugget of code, okay? And we can use it every time we want to know if the mouse is inside a circle. Okay? And then it's up to us here to decide, in this case, the outcome of that, right, can be declared over here, so that down the road, maybe I want to reuse this function in a different context. I may not always want to change the fill to different colors. Maybe I want to do something else. I can reuse that component over here that I just made to basically becomes like just a little shortcut, right? So I don't have to redo that calculation every time or rewrite that calculation every time. Of course, the code has to do the calculation, but we don't care about the code's feelings. So this is, these functions could be as simple or as complicated as you need them to be. But even here, for something simple like this, just a few lines of code, I think other than saving us the trouble of having to write this over and over again, which isn't really that hard, the other big benefit, going back to what we talked about in the first video this week, is we can start to replace lines of code here with words, right, with concepts. So to me, this is now a lot easier to understand what this program is doing, right? It says for every circle in this array circles, it checks first if the mouse is over, right, its coordinates, and then change the fill color, and then it draws the circle. Whereas before, we had just these lines of code, and we had to think about, okay, what does this do? Unless there was a comment, we had to understand and know that, okay, this is a distance calculation. All right, it's checking the diameter. This is probably a mouse over behavior, right? We had to make this mental leap in our heads to translate this into something that we can understand. Okay? And the more complex the code is, of course, the harder it is to do that every time. So when you start to package these little bits that you've already figured out into functions, you can then build the rest of your program much more intuitively. And you can start to replace code with labels, just like, variables are making things useful because we can replace numbers with concepts. We can start to do the same with entire sections of our code. And this is really important because there's only so much we can hold together in our heads at one time when we're programming. So as we create these building blocks, we can use them to build more interesting structures. Now we don't have to reinvent mouse is over. We can just use the concept in our program. We've made it ourselves because we needed it. But once we've did it, we can now think of in terms of these concepts instead of lines of code like this, which for the mere mortal are a little bit more abstract. So this is a really important idea to kind of think about this week, is how functions can really help us structure code, and in return, what we get is more expressiveness, right? If we are able to create more interesting things with our code more quickly, then we can be more expressive with it, right? We don't have to work as hard, and it kind of makes us, it opens up more possibilities just because it's more manageable. So this is a really, really useful idea. Okay? All right, so that's it for this week. We've basically covered more or less all that we need to know about functions, at least in the context of, declaring these named functions over there. We use the keyword function. Just to recap here, we give the function a name, and then inside the parentheses, we might decide to put in a number of parameters. Those are inputs into our function, so that every time we run the code, we can provide different values, kind of plug in different numbers. And then the body of the function, right, is curly brackets, just like every code section we've written from the start. And then inside that function, we put some code that we want to run every time we call the function, we use its name. And then sometimes we can use the keyword return to end the function and then spit out a value, spit out an answer, right? So some types of functions lend themselves really well to that. Other functions, like circle. Circle doesn't output anything. It's just going to draw a circle on the screen, and then when it's done its job, and we don't need to hear from it any further. Other functions like dist, right, do output a number. They output some kind of value that we can either store into a variable, or in this case, we don't need to put the answer to this into a variable because it is a true or false value. We can use it into an if statement. All right, so let's leave it at that for this week. I'll see you next time.